If you notice, let's say we position our gentleman at a plus roughly 3 meters. We give him 0 velocity and 0 acceleration. When we tell him to start the program and start the graph, we end up getting a graph of our position being a straight line, while our velocity is 0 because we told it he isn't moving, and our acceleration is 0. Now, if we look at our position, let's say we now have him, move him over here, and he walks to around -4. What happens? We get our position is in the negative direction, our velocity is still 0, and our acceleration is 0. Let's give him a little velocity. Let's make it a velocity in the positive direction. Let's try about 1. So what happens? He starts moving. Our position graph changes with a positive slope. So we now have our position graph changing because he's moving away from where he started in the positive direction. He's moving away at a velocity. Notice that our velocity is not on the 0. It's above the 0, so we have a positive velocity. But our velocity is not changing, so we have 0 acceleration. Well, what happens when we now say we have a negative velocity? Let's give him a negative velocity. What does he do? He turns around and goes back the other direction. Our slope of our position time graph is negative. Therefore, we have a negative velocity. Our velocity is not changing, so we have a 0 acceleration. Well, let's see what happens when we give him a 0 velocity. Let's start his position off at -4. But we give him an acceleration of a positive 1 meter per second squared. So what is he going to do? He moves off, and notice he gets faster as he goes. Does that make sense? Let's see, our position is changing. He's accelerating at 1 meter per second squared, so that means every second his velocity is going to increase. So after 4 seconds, he's around 4 meters per second for his velocity. He's increasing. Our position, we start out slowly moving further, and then as time goes by and we get faster, our position starts to increase. Okay, now what if our acceleration's in the negative direction? What is it going to do? Oh, he still kept going in the same direction. Why is that? Y'all tell me. That is the question to figure out. Why? Or do you think at some time would it turn and change before we ran out of road? That is the question I want answered.